Last week, I wired 3 agents together over Axel. Agent 1 called Agent 2, Agent 2 called Agent 3, and then Agent 3 crashed. Agent 1 had no idea, just sat there waiting, no log, no error, no path back. This is what debugging on Axel looks like today, and it gets worse with every hop. Axel is peer-to-peer, built on top of the EthGlobal mesh. You address peers by public key, end-to-end encrypted, no shared infrastructure. That's the value. But it means the agents you talk to know peers you don't. They're independent agents, forwarding work to other agents, MCP servers, anywhere their own connections lead. 3 hops in, you're orchestrating a network you can't see, owned by people you don't know, written in frameworks you didn't pick. When something errors down the chain, the error is lost in the void, and the network itself is invisible to you. My solution: a unified debug trace across every cooperating node. One workflow, one trace, end-to-end. To build it without inventing a new protocol, I leaned on the standard every language already speaks for distributed tracing: OpenTelemetry. Secure, low effort, framework agnostic, every major language and agent framework already speaks it. The one piece it doesn't have is a transport that fits Axel, so I made Axel itself the OpenTelemetry transport. Any agent or MCP server keeps its own OpenTelemetry setup and can configure it any way they like. The only change: point one OpenTelemetry endpoint at a remote sidecar. The sidecar stamps a peer ID into OpenTelemetry baggage and routes the span over Axel itself. For the demo, I have 5 agents running in different VMs. The editor is a simple LLM for writing reports. It only shares keys with 2 other agents, the researcher and fact checker. However, those 2 agents talk to a web search agent with a browser MCP and a fact checker with CitationDB. In the demo, I will have the CitationDB fail, showing a downstream issue with no direct connection to the editor. Here, I have a view of the mesh from the editor. When we submit our prompt, we can see without the sidecar, the editor can only see the researcher and fact checker, but no insight beyond the responses from any of them. Looking at Jaeger, we only see a trace of the editor. As well, when we check the graph, we can see that the editor only had visibility to the processes running in that agent and none of its peers or downstream MCPs. Now, with the sidecar running, submitting the same prompt will first detect its peers. As requests get routed back through Axel, the entire path is now visible to the editor. When viewing the full trace, we can see all the agents and MCPs involved. Expanding the CitationDB, we can see the error that was propagated back to the editor. Taking a look at the graph, we can see the communications and processes that ran on all nodes in relation to this request. After, even inspect the system architecture, providing a clean mapping of all nodes that have communicated with the editor. With Axel OpenTelemetry, you can finally debug large agent chains on the Axel network, making decentralized agents a viable architecture. For more information, please check out the GitHub.